Good evening and welcome to lesson 9.3, graph data. Before we begin, let's take a look at our essential question. How can you use a coordinate grid to display data collected in an experiment? All right, this is going to be a little bit different than the investigates we have done the rest of the year. This one you could actually do at home as an experiment. So, a couple of things that you will need is a paper cup, or you can just use a regular cup, a water, which is what you get out of the tap water, Fahrenheit thermometer, should be one laying around, but if not, I understand, ice cubes, and a stopwatch. And of course, you can use your phone, you can use your tablet, whatever you have to use as a stopwatch. So when data is collected, it can be organized in a table. So your table has already been set up for you over here that you can see. So we're going to start, we've got our label as water temperature. Our time is going to be done in seconds, hence the need for a stopwatch. And our temperature in Fahrenheit. Now, if you don't have a Fahrenheit thermometer at home, but you have a Celsius, feel free to use that and just record in Celsius instead of Fahrenheit. So, step one to the procedure is to fill the cup more than halfway with room temperature water, which is basically water that you get out of the tap. Make sure it's not cold, make sure it's not hot. Basically, the temperature of your wrist. Room temperature, around 70 degrees or something along those lines. The next step is to place the Fahrenheit, or if you have Celsius, thermometer in the water and find its beginning temperature before adding any ice. You're going to record this temperature in the table at 0 seconds. So as soon as you find out the temperature of the water, before you add any ice or anything, you're going to record it in this blank right here. Now, the next step is place 3 cubes of ice in the water and start the stopwatch. Find the temperature every 10 seconds for 60 seconds. So, after we put the 3 cubes of ice in, at the end of 10 seconds, we're going to record the temperature here. Then, at the end of 20 seconds, it's going to be recorded here. At the end of 30 seconds, it will be recorded here. At the end of 40 seconds, you will record it here. At the end of 50 seconds, you will record it here. And at the end of 60 seconds, you will record it here. Now, of course, you may pause the video as you're going through these steps. Now, for our draw conclusions, number 1, it says, explain why you would record the beginning temperature at 0 seconds. For questions 1, 2, and 3, these are going to be things that you're going to be able to answer based upon the experiment that you just completed. Question number 2 says, describe what happens to the temperature of the water in 60 seconds during the experiment. And the last one is our hot problem. It says to analyze your observations of the temperature of the water during the 60 seconds and explain what you think would happen to the temperature if the experiment continued for 60 seconds longer. So go ahead and record your thoughts on what you just observed during your experiment. And of course, you may pause the video right now to respond to those questions. All right, let's take a look at our Make Connections section. It says you can use a coordinate grid to graph and analyze data you collected in the experiment. So step 1 would be to write the related pairs of data as ordered pairs. Now these are also going to be basically different responses based upon what you received during your data collection within the experiment. So you would write the related pairs of data as ordered pairs. So it would be 0 and whatever we have. So now we've set up our table over here where it says to construct a coordinate grid, which is what this is, and write a title for it. Label each axis. So they've kind of done this a little bit for us. Our label is water temperature. Our x-axis is time in seconds, and our y-axis is temperature in Fahrenheit, or if you used a Celsius thermometer, temperature in Celsius. And of course, these numbers may be considerably different if you used a Celsius thermometer. Step 3 says to plot a point for each ordered pair. So you would actually go over using your ordered pairs from up here and put in the point for each of those ordered pairs. Again, you may stop the video in order to respond to these. Now for our problem solving, if you would go ahead and turn over to page 380, and in place of a password for tonight's lesson, we are going to complete this problem solving together. It says, Mary places a miniature car onto a track with launchers. The speed of the car is recorded every foot. Some of the data is shown in the table. Mary graphs the data on the coordinate grid below. So we have our table and we have our coordinate grid. And over here is where we're going to graph the data and correct the error. So it says, over here it has miniature car speed as the title. Our x-axis is the distance in feet, and our y label is speed in miles per hour. So over here our label would be the same. So we have our label, and now we're actually going to draw our x and y axis. So we'll begin with our x-axis. So now we have our x-axis drawn, and we are going to draw our y-axis. So let's draw our y-axis straight off. We have our y-axis, and down here we make our point for our origin, which is where they intersect. Now we got to provide a label for our x-axis, and we have to provide a label for our y-axis. So let's go ahead and do that. Okay, we have our label for our x-axis as distance in feet, and we have our label for our y-axis as speed in miles per hour. So the next thing we need to do is we need to take the data from our table and bring it down into our ordered pairs. So our first one is our origin of 0, 0. So we've already got our point drawn for 0, 0, or our origin. Our next ordered pair, oh, I'm sorry, let's backtrack a minute because we do have to put our numbers up for our x-axis and our y-axis. So let's go ahead and do that. Okay, now we have our numbers down for our x-axis and our y-axis. And if you notice, we did our y-axis in twos, 2, 4, 6, 8, 10. Okay, so let's go back to our ordered pairs. I do apologize for that. So we have our 0, 0s already marked. We have our 1, 4. So we know that the first number is always the x-axis. So we go over to the 1, and we are going to go up to the 4. So we're over 1, up 4, and our next one would be placed right there. So our next ordered pair is 2 and 8. So we would go over to the 2 and up to the 8. And that is where we would place our next point on the grid. So 2 and 8. Okay, our next set of ordered pair is 3 and 6. So we would go over to the 3 and up to the 6. So right there is where our next point on the grid would go. So let's go ahead and do that. Go over to the 3 and up to the 6. Okay, that's a little bigger, but get the point. Our next ordered pair is 4 and 3. So we would go over to the 4 and up, and we don't have the 3 for the y-axis, so we know that we have a 2 and a 4, but we do, number between that would be 3. So we're going to go over to the 4 and up to the 3, which would be in between the 2 and the 4. And right there is where our last point would go. So let's go ahead and do that. over 4 and up to the 3. So at the bottom it says to describe the error Mary made, because if you look at our grid and you look at Mary's grid, it looks very different. So what do you think the mistake was that Mary made? Well, if we look, we see that Mary reversed her x and y coordinates for the data. She put her distance on the x-axis and speed was on the y-axis, and technically it should have been reversed. So that's it for tonight's lesson. Be sure you record your information from your experiment, and we will see you in class tomorrow.